here. All right, so today the big thing is this is really what a sine graph looks like. We've been only doing this much of it, but really it is a wave. It goes on forever. We're still going to focus on that kind of section of it, but I kind of wanted to see if what would secant look like if you looked at the sine first. So I drew the sine in red so that I could draw the secant in blue and we could compare them, okay? Now, secant is the reciprocal of cosine. So since it's a reciprocal of cosine, what does reciprocal in math pictures mean? It flips. So if I take a section of this graph and I flip it, it would look like this. Because this piece of it looks like a U. Would everybody agree? So that piece flipped at the origin, at the vertex would flip up. And same thing's true down here. This one would flip down for that section. So what ends up happening is it breaks the graph apart into pieces that look like parabolas by themselves instead of connected parabolas. Because doesn't the sine look like connected parabolas? So I'd have another one over here and another one here at the top. Now, because of that, when you think about why is it doing that, the numbers will make sense. So let's go through again and talk about how do you get the numbers, and let's talk about, okay, and let's talk about all of those things that are the same as sine. So for secant, amplitude is still found the same way. So our amplitude in this question is, what's in front of it? 1. The period is found the same way as sine, 2 pi divided by omega. What's in front of x? 1. 2 pi divided by 1 is still what? 2 pi. Believe it or not, there are a few people on the quiz that said half pi. They just wrote a 2 down there like this. You see a problem with that? Yeah. Yeah, that was a big mistake on the quiz that a few people did. They just wrote it down. They just separated the two of them and wrote it separate instead of together. All right, now let's talk about scale factor. Well, how did we find it before? We divided by 4, so 2 pi divided by 4 in this case is where the half should have been. They just got a little ahead of themselves and put it on the period instead of the scale factor. And does this have any phase shift? No, this has no phase shift, so that is good because we can see what it would be like. It is for that part. Now, let's talk about also how do we make the table. And when we look at how we make the table, we know we want it to go by halves, right? But do we start on a negative number or do we start on 0?
0.
Okay, let's start on 0. I tell you what I'm going to do. I'm going to erase half of this graph over here so I have some room, but you can put it anywhere on your paper. But just to make it a little easier for those who are going to watch this later, I can put it over here. All right, so first of all, you said we start at 0 and we're going by halves, so that sounds very much like what we did before. That's just the numbers off the unit circle at the axis lines, right? Now let's talk about sine for a minute, and maybe that'll make sense on what a cosecant is. And as you think about this, let's see if I can move this over just slightly. All right, as we think about this one time we're going to put an extra column in here, and we're going to show what's the sine of that, and then we're going to talk about how does it become cosecant, so you can see how to get it in case you forget your cosecant numbers. All right, so what were those sine numbers that we used before?
0, 1, 0, negative.
All right, so those are our sine numbers, and if we had an amplitude, we'd multiply it in. But we don't have anything but 1, so we're still good on amplitude. But But secant has a very cosecant has a very unique set of numbers based on these. Now, you said we flipped the graph. That's because in order to get cosecant, the cosecant of an angle is 1 over sine of that angle. So that means you flip the answers too. So in order to flip them, they got to be fractions. So I stuck a 1 under this 0. What happens when you flip it? That's right. 1 over 0 is undefined. What happens when I put a 1 under 1 and I flip it? It's just 1. So here's another one that's undefined. What happens when I put a -1 with a 1 under and flip it? It's -1. And here's another undefined. Now let's locate those in our graph so you can see that relationship. There is undefined at 0. There is undefined at pi. And there's undefined at 2 pi. So those little parabolas that we reflected actually hug up next to those what we call vertical asymptotes, the breaks in the graph, and so you end up with some real parabolas instead of parabolas that are connected. And so that's kind of what cosecant does. It has 2 parabolas, one's on a positive, one's on a negative. And so it's pretty simple to graph without the sine graph being there. But I wanted you to see the two of them together so you could see it's just a reflection. Does that make sense to y'all? Now what we need to do is we need to add some numbers in here so that you can see maybe a shift. Maybe you can see an amplitude that's different. Maybe we can even see a scale that's not going by halves. So we're going to look at another couple of examples with different numbers in different places. And at the same time, we're going to keep coming back and referring to the fact that cosecant has a very good set of numbers to use because there are only 2 of them are numbers. Yes, ma'am.
So X for secant or cosecant. Which one are we doing?
I'm doing cosecant right now, but secant does the same thing.
Okay. Will it start on 0?
This one does. The other one doesn't. The reason this one starts on 0, cosecant starts on 0 because sine does, and those are the 2 that are beside each other in our list. Cosine doesn't start on 0, so secant won't start on 0. But because they both have the same list of numbers here for sine, the fact that the sine of an angle and the cosine of the angle are the same, when you flip them, secant and cosecant have the same list.
So the list stays the same for y?
Mm-hmm. All right, let's do another one. So, y equals -2 cosecant of x minus pi. Why is it going to reflect? Because there's a negative in front. The only way that wouldn't reflect is if I could turn the parentheses around and keep the negative. Well, first of all, you have to have a parentheses that's backwards, and we don't have that. But it is possible that it would not reflect with a negative in front if you had that situation. So you always got to look at your parentheses over there and make sure it's in the right order before you decide if it's reflecting, but this one is in the right order. What's my amplitude? It's 2. That number in front of the word is your amplitude. Now, in this particular case, our period, what number is in front of x? 1. So a period might look like it's going to be the same as it was before because I've divided by 1 and got 2 pi, but this problem has a shift, so our table at the end won't look the same. Our scale factor again is pi divided by 2, but our phase shift is x minus pi equals 0, and what does that make it do? Right, left, what? Add pi makes it go to the right. So one of the things I noticed yesterday was people forget to write the word right down here. Part of the problem with graphing is being able to distinguish what everything in your graph is doing for you. So we write reflect because there's nothing down here that we can attach that to. And we write right next to this because that tells us which direction. That's very important because it means we're going to add those to our table. instead of subtracting them. And that should make our graph not start at 0 anymore. So, it did start at 0 and go by halves before. So that's the same numbers we just had on the last one. But now we've got to add a pi to each one because we're going to the right. So if we add pi to 0, we get pi. If you add a half to a whole, what do you get? Right, because 1 plus a half is 1.5, and that's the improper fraction, 3 pi over 2. If you add a whole to a whole, you get 2 pi. So what this is really doing, if you had a common denominator thing going on here, this would be 2 over 2, 3 over 2, 4 over 2. So the next one should be what? 5 over 2. And then 6 over 2 would be 3 pi. So you can think about it with a common denominator, and it'll give you that opportunity to just count if you get the common denominator thing going. Or you can just add fractions. So there's my x's. Now let's talk about our y's. Again, we started with 0, 1, 0, negative 1, 0, but because we're doing cosecant, we flip those. So to catch Megan up here a little bit, if you take 0 and flip it over, you put a 1 there, flip it over, that makes it 1 over 0. I can't divide by 0, so it's undefined. If you take the number positive 1 and you flip it over, it's still 1. 0 flipped is undefined. Negative 1 over 1 flipped is still negative 1. And the last one's undefined. But I have amplitude. So what am I going to do with that? Yeah, and make sure you pick up the negative up here because a few of you left the negative off yesterday. Now, really, do you need to multiply undefined by negative 2? No, just the two that have numbers. Because undefined is undefined. It's not going to change. So now that we've got our list of numbers and we've multiplied them by the amplitude, I don't see anything else I need to do. I've used everything. I used the negative 2 in the y column, and I used what was in here on the x column. So I've used everything I need to use. I can graph it. Now again, when you graph these, this may start at pi, but what am I supposed to be going by based on looking at these numbers right here? Yeah, pi over 2 is my scale factor, and I can see these are by halves as well. So I still need to be going by halves. So I have to put pi over 2 on here, even though I don't have it on my list up here. That was another small error from yesterday's quiz, is starting your table on what the graph instead of starting your scale factor on your graph. The Audio and Power School, been there since yesterday. I have heard some students say they reloaded a new app because you have to have a new one to do the cloud, and it started working better for them, but they had to load it from not here because it's too slow.
Mine worked here just now.
Yeah, once you get it loaded somewhere else, because it spins too slow to load the app here, it works better. All right, so we've got our numbers across the x-axis. We need to go up and down to 2. So 1, 2, down, negative 1, negative 2. And the other thing that we need to do is, when we're graphing this, put the undefineds in first is very important, because those are vertical asymptotes, and they're just dotted lines on that number. So we're going to put a dotted line down through pi, a dotted line through 2 pi, and a dotted line through 3 pi. That's your undefineds. And then, once you get your undefineds in there, you're making two parabolas, is what we found out cosecant looks like. So you'll graph the first number, which is 3 pi over 2, negative 2. So I just go down to negative 2 under 3 pi over 2, and I have to draw the parabola down because it's in the lower part of the graph. So if you plot a low point, you want to make it open down. If you plot a high point, you want to make it go up. So that means 5 pi over 2, 2 would be up here. And you just make it curve in, make a parabola that kind of looks like it's trying to touch those dotted lines, but it really never does. And so that's what cosecant looks like. Now secant looks very similar because cosine looks similar to sine, right? The only difference between the two of them is where they start. That is the only difference. Sine starts on 0 and cosine starts one line back, right? Same thing. Cosecant always starts on 0, secant always starts one line back. Other than that, it's identical. Absolutely. And the nice thing is if you can't remember that, you can just flip the sine ones and you can get it. Or you can flip the cosine numbers, which happen to be the same numbers, and you can get it. So that's good because sometimes that makes us have to memorize a little less. All right. So in our next example, let's put a number maybe in front of x, and maybe let's put a number on the end so that we have every possible thing that it can do. Up, down, left, right, bigger, smaller, whatever we need. How much more you need, Megan? Okay. And I'm recording this so that the people who are out can watch it. That's why yeah. I just thought that might be a great way for them to get caught up since they're going to miss almost the whole class period, they said. Yeah. So that, and by then we might be working on something else and they've missed the whole lesson. So I thought I'd record it. I'm just trying out some new technology, see how it works, let them try it, see if they think they could, if that helps them. Then in the future I could record something and send it to people when they're out so they can learn what we did while we were out.
Oh gosh, it's like you do that. You're like hoping to like send it through email.
Yeah. And when you get your Chromebooks, I could just share it with you. Because I can put it in the Google Drive and say share, which is, because all of you are going to have a Gmail account that the school has set up. So it'll be real easy for me to do because I can type your name in and your email address will come up.
If I already have a Google thing, do I have to use the school one?
Yes, because that's what your Chromebook login is going to be set up with. So you'll have to.
Wait, are you recording right now? So they're going to have to listen to this too?
Well, they need to know it too. All right, you done, Megan?
You learned this on Tech Tuesday?
This I didn't, but somebody told me about it, so I thought I'd try it. But some of the other things that we've learned, I tried at first to do recording with the Screencastify, but I realized that only records what internet window you have open. So then I had to try smartboard recording. All right, so let's see what we can do with 3 cosecant of 4x minus 1. And I stuck the parentheses in there already, but if I had not written those parentheses, how would you have known only the 4x was in there? Right, that's all that can be in there if they don't tell you more, right? All right, so in this case, we are looking for reflection. Do we have it? We do not. So our amplitude is just going to be what? Just 3, this number in front. Our period this time is definitely not going to be 2 pi because we have a number in front of x now to use to find a new one. So 2 pi divided by 4 reduces to pi over 2. Now our scale factor is that divided by 4. How do you divide a fraction by a whole number? You have to flip and multiply, so put a 1 under the 4 so that you can flip and multiply it and get an 8th. So I got to go by 8ths this time. And then the last thing is, does this have phase shift? It does not, because there is no adding or subtracting in the parentheses. Then what in the world does this minus 1 do?
It minuses the one after you multiply your...
And how does that affect my graph?
It shifts down. It shifts it down.
Yeah, this one does down. And here's how you know the difference. This negative 1's outside. Anything outside affects y. Anything inside affects x. So that's a pretty good clue that it had to do something to y. Now, yes, actually, you're supposed to write that down. I noticed a few people. I didn't this time, but I will next time, because I thought I stressed that, but I was stressing so much about writing reflect that I think some people didn't notice that. All right. Now, we already know our y values for cosecant stay the same all the time. So, undefined, 1, undefined, -1, undefined is what you start with. It may not be what you end with, but that's definitely what you start with every time you do a cosecant. Now, what do I do to the x's? Where do I start? What am I going by?
Start on 0. You start on 0, you go up however it is.
All right, and then somebody said something about multiplying by 3. I'm definitely going to take that y column and multiply by 3 and subtract the 1. Okay, so first let's number this by 0, pi 1/8. What's 2/8 reduced? A fourth. What's 3/8 reduced? It doesn't reduce. What's 4/8 reduced to? Pi over 2. And because I started on 0, it actually stops on the period number, which is good because that's a check for me to see if I did it right. And then you said I need to multiply by 3 and take 1 away. Do I need to do that to undefined? Oh, okay. Just the ones that have numbers. So what's 1 times 3 minus 1? 2. What is -1 times 3? Minus 1. Got stereo going on today. Alright, so let's look at our graph. So this time I still don't need a lot of negative x's. Definitely need a little bit different on our y's because it's uneven. I got more negative than I got positive. That's okay. No one said a graph has to be even. So I only need 2 lines going up in the positive area, but I need 4 lines going down to get to -4. So they don't have to be even. Just like the origin doesn't have to be in the center. Does mine look in the center? Alright, so what do I draw on my graph first because it helps me? The dotted line. So I'm going to put 1 at 0, 1 at pi over 4, and 1 at pi over 2 because that's your asymptotes. That's what undefined does. It draws a dotted vertical line in that really isn't part of the graph. It just helps you to curve your parabola to it. Then you plot your point. If your point is high, you make it go up. If your point is below, you make it go down. So our highest point was 1/8 2. So we'll go over to 1/8 and up 2 and draw a parabola up. And then my lowest point was -4. And we make it go down. And it probably needed to be a little bit bigger than that, but I ran out of room at the bottom of the board. You want to make it hug up next to those green lines as much as possible to have a good sized parabola. So what do you think about cosecant? So what's the big difference between cosecant is the undefineds, right? And otherwise, everything is done exactly the same as you did sine and cosine. So let's look at secant now. Maybe do a couple examples of that to see if we're on the right track. Maybe we need the generic one first, just to make sure that everybody sees that it's the same. So y equals secant of x. Let's start off with our general information. Then we'll make our table. So in the general information, amplitude is always at the front. I don't see anything, so it's 1. Period is always 2 pi divided by omega. And what do we have in front of our x? Well, I don't see anything. So, right, because I'm going to divide by 1. And then 2 divided by 4 for the scale factor is going to be pi over 2. So that's our standard numbers. And again, the reason those numbers are so important is that's the numbers on the unit circle that have the nicest answers. You see, I could be mean and make you go by 12ths on every graph, and even graph the square root of 3 over 2 and the square root of 2 over 2, and all those bad numbers are on the unit circle because they're not whole numbers. But see, then your graph would have a lot more points, but it wouldn't be easy to do, would it? And then, of course, this is none. So let's look at our table. So our table sounds like we're just doing the same thing we did before. Same thing we did before. But this time it starts on a negative number. Why? Because what is this the reciprocal of? Cosine. See, this is equal to 1 over cosine. So since cosine doesn't start on 0, secant doesn't start on 0. So it backs up one line just the same. But so that's a good, but at least it does something similar to cosine. So we went by halves, but we started at negative pi over 2. Now your y values, since your little list, 0, 1, 0, negative 1, and 0 is the same for cosine and sine, that makes secant and cosecant have that same list. So undefined, 1, undefined, negative 1, undefined. I mean, you can't flip the list and get a different set of answers if sine and cosine have the same list, secant and cosecant have to have the same list. The only thing that makes this graph different is the fact that it might go through an axis a little differently because I backed up a line. You see, when we looked at cosecant, right, I pressed the wrong button. When we looked at cosecant, it hugs the y-axis. It don't actually touch it. Now when we graph, this is going to have a 0.01 on the y-axis. Does that make sense? So when I put my negative pi over 2, dotted line, I put my pi over 2, pi and 3 pi over 2, pi over 2 and 3 pi over 2 also have dotted lines. Maybe I should make those in a different color so they show up. But my points, those two nice numbers that we have, 0, 1 is over to 0, up 1. Draw a parabola up. And the other one is pi negative 1, which will make me open my parabola down because the higher of the two y values has to be the one that opens up. So the other one has to do the opposite. Now I know in this particular case, because I didn't take a good amount of time to make my lines spaced apart real well, it looks like my first parabola is a lot skinnier than my second, and that's what sometimes happens if you don't use a ruler. And they're supposed to look the same size. All right. Wonder what happens if it reflects. Okay, so it just looks like that and it'll be flipped. All right. Wonder if we could change the size of those. Wonder if there's some way to make them change size differently.
I feel like you wouldn't ask that question if there was.
Probably might not look it though if we're hand drawing them. But they do change size. If you take these and type them in y equals, you'll see some of the parabolas look like a heartbeat monitor kind of thing going on. They get really, really close together. And then some of them look really, really wide apart because your calculator makes a scale that's a better scale than we can draw out on paper. So I'm not so sure we'd see that. But let's look at, let's see what I've got over here. Wait a minute, let me change that. We'll do something different. We want to do two more examples, and each one of these examples is going to have a phase shift because it's important for us to look at phase shift and make sure we understand what happens to the problem. So before I even start the problem, I see something wrong with this equation. What's wrong with it? Alright, so I need to turn the 3x and pi around, which makes me take a negative out of it to get it to look correct. But then I got to know, do I drop that negative? So if that goes back to which word is this the reciprocal of? I drop it because secant is the reciprocal of what? cosine. And so because secant is the reciprocal of cosine, I don't need to bring it out here. I drop it because it does the same thing that cosine does. Same as cosine. Even function. It's an even function. It throws a negative away. But notice it didn't throw this one away. This one has to stay there because it was in the original problem. But the one I take from turning the subtraction around, I have to decide whether to bring it to the front or throw it away. I dropped mine because this is an even function. If that had been cosecant, I'd have multiplied it times the negative in front. So, that means this one reflects. So my amplitude is 4. My period is 2 pi divided by what's omega in this question? 3. And every time we've had that, it was pi over 6. But just to show that again, you'd multiply by 1/4. 2 cancels in a 4 2 times. So when you multiply the bottom, 3 and 2 make 6. And then I'm just going to move up here for phase shift so I don't have to go down so far on the board. I set 3x minus pi equal to 0, or I could go back to the original one and solve it, and I'd get the same answer. Because don't you add to get rid of subtraction? And divide. So which way does this one move?
Right.
To the right. Because it's positive. So now we've got to adjust our y and our x values, 1 for the phase shift and 2 for the amplitude. So our problem says that we're supposed to start our scale factor with pi over 6. Do I start on 0 or do I start with a negative? Negative. Pi over 6. Well, I should move that over a little bit. It's a nice thing about writing on a smartboard. You can just touch it and move it. Can somebody get that? So we've got 1626 is pi over 3. 36 is pi over 2. Now we are going to add pi over 3. So in this problem, I'd have to get a common denominator and make them all 6s if I didn't know how to do it in my head. But to save a little bit of time, I'm just going to do them in my head because I can do that. I know how. Third, take away 6 is a 6. This will be a third because it's adding 0. A 6 and a third will end up with being 3/6 or pi over 2. This will, yeah, 2 pi over 3. And now you can see sometimes there's a pattern. It went from 1/6 to 2/6 to 3/6 to 4/6, so this has to be 5/6. Because you can make them all 6s. On our other column, we have undefined, 1, undefined, -1, undefined. And what are we multiplying by? -4. Is there any adding in this question or subtraction for the end? All right. So that's going to kind of change our problem slightly. So we start at pi over 6. And we number our paper. Pi over 6 was our scale factor. But it ended up, it shifted over, so it starts on a positive pi over 6 instead of negative. That's all right. And if y'all want to, y'all can just not. This is it. This is all I'm going to do. And this will be finished recording. 1, 2, 3, 4. 1, 2, 3, 4. All right, so we're supposed to put dotted lines for undefined. And where am I plotting this one is pi over 3, -4. So we'll go over to pi over 3 and down to -4. And how do I know whether I open that up or down? Yeah, usually if it's below the x-axis, that's a pretty good clue. But once in a while, if your graph shifts up, that dot might be above the x-axis. So I always look at it to see what these two numbers are, and the negative one always opens down, or the lower number always opens down in case they're both positive. And so then I come over here to +4, and I make this one open up. And typically they'll look the same size if you use a ruler. So secant and cosecant do the same thing, just one of them starts on 0 and one of them starts on a negative, just like sine and cosine. Otherwise they're exactly identical to how you do them. All of this is exactly identical, it's just the shape of the graph is different. That's really the only big difference. The column of numbers you use. The math's done the same. So, is that enough for everybody?